For each statement in 20 through 32, determine whether the statement is true or false. Prove the statement directly from the definitions if it is true, and give a counterexample if it is false. For all integers a and b, if a divides b, then a squared divides b squared. So d divides n means that there exists an integer k such that n equals d times k and d does not equal 0. So we can use this definition to try to prove this statement if we need to. Now, first let's figure out whether this is true. I'm going to pick two numbers a and b such that a divides b. We could do 12 and 36. 12 divides 36. That's true. 12 squared is 144, and that's my a squared, 12 squared. My b squared would be 36 squared. 36 times 36 is 1,296. And so now we have to ask ourselves, does 144 divide 1,296? Well, if we do 1,296 divided by 144, we get the integer 9. So it looks like the statement is true, but we're going to need to prove that it's true. Since we're proving a universally quantified statement about a and b, let's instantiate a and b as integers. Since we're proving an implication, let's assume the premises of this implication and try to conclude somehow that the conclusion of the implication is true. So assume a divides b. Then we can explain what that means by definition of divides. B equals a times k for some integer k. Now let's first figure out what we're trying to show. At the very end, we want to conclude that a squared divides b squared. But what would that mean? That would mean that b squared equals a squared times some integer s. So what we really want to show is that b squared equals a squared times some integer m. Now, this equation right here is very similar to this equation. What we could do is we could square both sides of this equation and see what we get. So by squaring both sides, we get b squared equals a times k all squared, which if we simplify that, that's a squared times k squared. Now, since k squared is the product of two integers, k times k, then k squared equals m for some integer m. So b squared equals a times k all squared, which we algebraically simplified as a squared times k squared. And the important thing here is that this right here is some integer. So b squared equals a squared times m for some integer m. By definition of divides, that means that a squared divides b squared. Now, if you're wondering, wait a minute, doesn't this letter have to be k where this letter is m? Well, keep in mind here, what matters is that a squared is being multiplied by some integer. It doesn't matter what the letter being used as a placeholder is. What matters is that a squared is multiplied by some integer. Thanks, everyone, and I'll see you in the next video.